Hello and welcome back to Communicable, the podcast brought to you by CMI Communications, ESCMID's open access journal covering infectious diseases and clinical microbiology. My name is Angela Hudner. I'm an infectious disease doctor at the Geneva University Hospital in Switzerland and editor-in-chief of CMI Comms. I'm joined today by my co-host, Nav Narayanan, infectious disease pharmacist and clinical associate professor at Rutgers University in New Jersey and fellow editor at CMI Comms. Nav, delighted that you're here with me today.
I'm glad to be here again, this time with you, Angela. It's a pleasure.
So the topic today is avian flu. We are delighted to have with us Professor Ron Fouchier, virologist and deputy head of the Erasmus MC Department of Viroscience in Rotterdam, the Netherlands. Ron is known for his extensive research on respiratory viruses of humans and animals. In addition to his work on avian flu, his team has contributed to the identification and characterization of new viruses, such as human metapneumovirus, SARS coronavirus, MERS coronavirus, and others. Ron, we're really happy you're here. Thank you for coming on the show.
It's great to be here, Angela and Nav. Great to be on the show with you.
We start all the episodes to learn about our guests and even our co-hosts. So what I'm going to throw out to you guys today is, assuming that you have all the qualifications you need, whether it's intellectual or physical attributes, what would be your dream job if you weren't doing what you're doing today? And I'll start. I'm reading right now one of Stephen Hawking's books, A Brief History of Time. So if I had the intellectual capacity, theoretical physics and cosmology would be probably at the top of my list if I wasn't playing American football professionally.
So you got two in there, by the way.
I do. Professional football player by day and then theoretical physicist by night.
So mine is not very original. I think it's the dream job of maybe half the planet. I would want to be a travel writer. It would be so cool. I get to travel and sit in front of my computer with my coffee and write.
The economy is also geared towards your dream job as well. So you don't have to worry about financial stability too. All right.
Yeah, of course, I'd be like a highly successful travel writer. It's my dream, right? So anyway, Ron, what's yours?
Before I decided to study microbiology, I wanted to become an engineer, like hydraulic engineer, water management, irrigation type of stuff. And then last minute, I changed to microbiology. But if I would have to think now, then maybe a forest ranger or wildlife manager or something like that would be really cool. Being out there in the forest, I think it's nicer than being behind your desk all day. Being in the lab was great, but being in a forest might beat being in the lab.
I love that. Yeah. I'd like to see you out there herding bison and other things like that when you're not discovering viruses.
Yeah, it is related, of course, also to my interest in infections, but it would be nice to be out there more and behind my desk less. We do a little bit of work also on wildlife, of course, with birds. And so I go out occasionally, but it's now limited to maybe once or twice a year. And then you could do it every day. It's great.
So to more serious matters now, avian flu, or should we say avian influenza subtype A, in parentheses HXNX, is what I've learned is how we are supposed to be calling it. As a reminder to our listeners, the H and the N are the hemagglutinin and the neuraminidase proteins on the surface of these viruses. And these are the antigens that elicit a response from our immune system. So Ron, for our non-virologist listeners, can you give a brief refresher on the characteristics of seasonal, so human influenza, let's call it, those human viruses versus those of avian influenza? Why is avian flu so much more pathogenic? And then if you can just give us an overview, how many known subtypes of avian flu are there and which ones are the most worrying right now?
All right, that's a lot of questions in one. I start backwards about the diversities. All avian influenza A viruses arise from the animal kingdom, and a major reservoir for avian influenza is wild birds. In wild birds, there are now 17 hemagglutinin subtypes recognized and 9 neuraminidase subtypes. So that gives rise to 9 times 16 variants of H and N. There are also 2 subtypes found in bats, 17 and 10, and H18 and 11 are only found in bats, but all of the others, like H16 and 9 and so forth, are all found in birds. And the latest addition is H19. So H1 through 16 are avian, H17, H18 were found in bat, and now H19 is again found in birds. And so the human viruses originate from the avian viruses. And so H1, H2, and H3, the first 3 hemagglutinins, have been found in humans to cause pandemics and subsequent seasonal epidemics. And so all of those three subtypes, H1, 2, and 3, originate from wild birds at some point in time. Now, currently, we are dealing with major outbreaks of avian influenza in poultry, primarily caused by a subtype. And this is a bird flu virus that originates from wild birds, but has spilled over into domestic birds back in 1996 already in Asia, then caused outbreaks initially, of course, mostly in Asia, but then starting 2005, it started to spread out of Asia to different parts of the world, initially Africa, Europe, but most recently also North America, South America, Antarctica. And this is a virus that is very virulent in poultry, so it kills poultry really quick, but since the last 10 years or so also have caused major damage to wild birds and started to spread in wild birds and wild mammals. Now, you say that this virus is particularly hot or virulent, but it's mostly virulent in birds, right? So it's extremely lethal in poultry. Poultry can die within 24 hours after getting infected. Wild birds can also have considerable morbidity and mortality, but this virus is not particularly lethal in humans, as it seems at the moment.
That was a great overview, Ron. And I think that's notable, especially for non-virologists or even just non-healthcare folks that might be listening, about the distinction of the lethality in birds versus in humans and how those don't necessarily translate in terms of the virulence of the virus, depending on the host.
That's right. In birds, the virus causes a systemic disease. The H5 and H7 highly pathogenic viruses, they replicate systemically. You can find it all throughout the organs of a bird. And we don't see that in humans, even with the same virus, the H5 virus. If you go back in autopsy cases of fatal human cases, this is not a systemic virus in humans. So you cannot really do a one-on-one comparison of the pathogenicity in humans and birds.
We've seen that in the other way, where there's asymptomatic animal carriers and then highly virulent disease in humans, but it can obviously be the opposite or vice versa. Before we go further down this road about the current avian flu, I think it would be nice for myself as well as the listeners to look back at the history of this and try to understand the development from an evolutionary standpoint. What's the timeline of the development of these viruses? When did it hop over? Do we have some sense of the evolutionary biology of how far this goes back?
Avian influenza viruses have crossed over from wild birds into poultry throughout history. I think that the first disease caused by influenza virus was in fact a disease recognized in poultry. And so this has happened over the last century, time and time again, that viruses of wild birds enter poultry and then start spreading massively in poultry. And because of the intensification of the poultry sector across the world, we also see an increase in the number of outbreaks across the world and the size of those outbreaks. So over the last 50 years, we've seen an increased number of new introductions of viruses from wild birds into poultry and then problems in poultry. The outbreak that we're discussing today mostly is the H5 outbreak. And this one that we're dealing with now in North America, South America, and also Europe is one that started in 1996. Mainland China was first detected in domestic geese, and it was first recognized only in 1997 in Hong Kong when 18 people were infected and 6 of those people died. At that time, it was not known that avian influenza viruses could infect humans and kill them. It was never seen before, and so there was a big scare. At that time, the Hong Kong authorities quickly found out that these human cases were related to outbreaks in the live poultry markets of Hong Kong, and the authorities decided to kill all the poultry in the live poultry markets. And that stopped further human cases, and of course stopped also the outbreak in poultry in Hong Kong. But what was not known at that time is that the virus originated from mainland China and continued to circulate in mainland China ever since. And in mainland China, of course, the way poultry is being raised is very different from the Western world, with a lot of outdoor ranging ducks and geese that mingle with wild birds. And so it's not so surprising to see that there was subsequent spread of the highly pathogenic H5 virus from poultry by wild birds to surrounding countries. And so from 2004 onward, it started to spread out of China into other parts of Asia and Africa. And then later, 2005, 2006, into Europe. In several waves, it entered in Europe all through migratory birds. And on 2 occasions, it had spread further from either Asia or Europe into the USA, the first time across the Bering Strait, and the last time a couple of years ago across the Atlantic into Canada. And so this last event, that started around 2020. It spread from Canada across North America, then in South America, and it even landed all the way down in Antarctica. And so this is still the same lineage of virus, which we refer to as the goose guangdong H5 lineage, that has really had an unprecedented spread in wild birds, in poultry, and in mammals.
A quick piggyback off of that. In 1997 is the first jump into humans from these avian flu. Is that a function of the change in biology of the virus, or more of a function of just the probability increasing with the changes in poultry markets over the decades and an inevitability where this jump was going to happen? Or did something change drastically in terms of the virus?
No, I don't think that anything changed drastically with the virus. I think we've seen zoonosis with bird flu viruses before, but it was never recognized. Of course, in this case, we're dealing with a highly pathogenic avian virus that for some reason also caused severe disease in humans. That's why it was noticed. And perhaps the reason for this particular virus to do that is because of the internal genes of the virus. So Angela just mentioned the H and N proteins, which are on the outside of the particles, but inside there are internal genes that encode the polymerase complex. And this gene cassette of internal genes is very similar to the gene cassette of other zoonotic viruses in Asia, known as the H9 and 2 viruses. And it's probably this combination of internal genes with the H5 and N1 surface proteins that made this virus particularly zoonotic and causing severe disease in humans. And that's why it was noticed so early in 1997. But zoonosis with bird flu virus occur more frequently. We also had an outbreak in the Netherlands in 2003 with H7N7 viruses, where more than 90 people got infected, and one of those individuals also died.
Coming back to 2024, can we say how widespread H5 avian flu is right now? Do we have an estimate of the percentage of wild birds that have been infected? In which regions? Which species are the most affected?
I think it's safe to conclude that the H5 goose guangdong lineage is currently almost global. I think the only part of the world where we haven't seen circulation yet is Oceania. But I pointed out that it has spread all the way from China into Europe, into Africa, into North, South America, and Antarctica. So it's truly a panzootic, so the equivalent of a pandemic, but now in animals. It's being spread by wild birds, and the typical wild birds that spread avian influenza are ducks, geese, and swans, so water birds, and also gulls and terns. And I think that's no different in this case. So the real spread of the virus, of the H5N1 virus, is happening through those migratory water birds. Now, occasionally you will see infections of other species of birds, like raptors, that will predate on sick or dead water birds. So it's not exclusively found in water birds, but the water birds, I think, are the real vectors. And so whenever we see new episodes in water birds, that's when you start to see major spreading of the virus, for instance, from Europe into the Americas. Now, what percentage of birds gets infected is a really tough question. So we have seen outbreaks here in the Netherlands in colony breeding seabirds, where 99% of the birds die. These are sometimes colonies with 10 or 20,000 birds, where all of the juveniles die in one summer. But of course, if you look outside, there's plenty of birds that are still alive, and the ecosystem is pretty strong. And so it's never an outbreak that rages through all the birds at once. And so we now also find that 30% or 40% of those same species where we've seen outbreak have antibodies and presumably have survived the infection and are now at least partially resistant. It's really hard to get to the numbers of the animals that have been infected. If we look in major vector species like American Eurasian widgeons or mallards, we can see seroprevalence up to 50%, and also in terns and in gull colonies we see that. So it's highly present, or it has been highly prevalent, and a lot of birds luckily have survived the infection.
And what about other animals? What about cows, dairy cows, for example?
The virus has spread, of course, to various mammal species. Let's start with wild mammals. So that we've also seen a lot of predation on sick and dead birds, and that has resulted in at least 50 species of mammals becoming infected over the last couple of years, last 3 years alone. And in the Netherlands, we've done some prevalence studies in red foxes and in martens for the prevalence of antibodies, and we find seroprevalence of 30 to 40% of our red foxes and martens. Because the virus has been been so widespread in wild birds, and sick birds and dead birds are easy prey. We see in carnivorous mammals, we see a lot of infections also. Now, the most recent mishap with the bird flu virus is that it also entered in cows in the USA. It's now also widespread, detected in at least 192 farms. When last time I looked, in 13 US states. This virus is now spreading in cows via the udder. The transmission is very different from everything I just told you, which is happening in the wild by predators feeding on infected birds. Here in cows in the US, the virus seems to be spread by milking machines from udder to udder. There must be one rare event or few rare events of virus entering into the udder of cows and then spreading onwards through milking operations.
And what is happening in cows once they get infected? You note that there is no real systemic infection in humans. Is it the same for cows, or are they more like birds?
Yeah, it's very similar to humans. And in fact, the virus is largely contained to the mammary glands, to the udder. So you'll find a little bit of virus sometimes in the respiratory tract, but very minimal. It's very clear that this is not a systemic disease. Of course, cows produce a lot of milk, and therefore cows also produce a lot of virus. Massive amounts of virus, 10 to the 6 per milliliter of milk, but then you know how many liters of milk is produced by a cow. You can imagine how much virus goes around in dairy herds, and therefore it's not surprising that sometimes this virus also ends up in the respiratory tract or in the throat of cows, and also occasionally spills over into humans because of the vast amounts of virus that are being produced in the udder of an infected cow. But it's not being spread systemically. The cows seem to have relatively mild symptoms, of course, a huge drop in milk production and the quality of the milk, but most cows do not seem to suffer much from the infection.
In these farms where the cows are testing positive, I would assume that there are protocols in place where their milk cannot be used. So we can just reassure our listeners, when a cow is testing positive, their milk is not being milked, correct?
I wish that were correct.
Oh no.
Of course, first of all, the milk production reduces quickly, so there's not much milk being produced after the infection is well established. It's clear that the virus-infected milk has entered the commercial process in the USA. That can be the case because some cows were not diagnosed with the disease before the milk entered into the production stream. Luckily, the pasteurization process is thorough enough to inactivate the virus in milk, and so consumers of pasteurized milk do not seem to run any risk of getting infected. The problem is, of course, that there's also some people who like to consume raw, unprocessed milk, and that would be particularly unwise at this present day. I don't think there's a formal ban still, unfortunately, on drinking raw, unprocessed milk, even in the USA. So I think that's a very unfortunate case, because it's clear that if you consume infected milk, that would pose a risk to you. It's clear also that in the farms in the USA, mice have become positive, cats have become positive and die as a consequence of the infection, presumably because they get exposed to contaminated raw milk. We also know that other animals, like the wild carnivores I just talked about, when they consume infected material, they get infected themselves and can die of the infection. So consuming raw milk is not wise. It poses a serious risk to human health and should be banned. But as long as the milk is being pasteurized properly, there should be no risk to humans for consumption. Personally, I think that it would be wise to eliminate high virus load in milks and to process that milk separately from clean milk. But to what extent that is possible in the US is not so clear to me. And so we're currently really relying on the pasteurization process to safeguard human health.
I think that's a good point of unpasteurized milk and dairy products in general, too, right? Because there are other potential infectious complications that can happen as a result of that. And so this is just another potential pathogen on a long list of potential illnesses that can happen with consumption of unpasteurized dairy products, including milk. The Centers for Disease Control and Prevention, our CDC, the last reports, I think, were showing that there were 14 cases detected across the US, as you said, as a result of farming practices across dairy and poultry. I think 13 of those 14 cases have been March of this year. What is it like in other countries right now? You mentioned outbreaks of different types of avian flu, but this current flu pandemic, is there human transmission that has happened? Are there the same type of cases that we're seeing here, or is it relatively unique to the US because of our farming practices and and how that might differ from other countries around the world?
Since 1997, the first cases of H5 infection in humans, there have been about 1,000 cases of humans getting infected with H5 viruses. Virtually all of these were directly related to human-animal contact. So there's been extremely little evidence of human-to-human transmission. There have been a few cases of household transmission back 2005, I think, in Indonesia, and maybe there were some cases in Egypt where household members were infected. And in those cases, it's very difficult to exclude the possibility that they were infected by a common source, like present in unprocessed chicken or something like that, or through direct contact. But at least in Indonesia, I'm aware of a few family clusters where it was likely that there was human-to-human transmission. But this is really unsustained, very inefficient human transmission. So in general, I think it's fair to conclude that this virus does not yet have the ability to efficiently transmit from human to human. This is also what we see now in the US. So the 14 recent cases, I think the 4 of them were in dairy farms and the other 10 in poultry farms. So these are people, of course, with very high direct contact with infected animals. The milking sector is really not well laid out to protect humans from becoming exposed to droplets of milk, of course, because this is not a contamination of humans by milk is not a phenomenon that we know from the past. So the whole process is not designed to fully protect the farmers from coming in contact with milk. And so now, of course, it's recommended to use PPE, but this is not normal for the milking workers. The poultry workers are generally the people that are involved in culling operations. And of course, those people would go into huge poultry houses with a lot of dust and fecal material. And so it's not so surprising they will get infected there as well. So, of course, when you use appropriate PPE, personal protective equipment, those infections can be prevented. But all of the cases so far have been directly through animal exposure. And in the historical cases before the US, most of these cases would occur in live poultry markets in Asia or Africa, or associated with culling operations and cleaning up operations of infected premises. So very similar to what we see in the US, and luckily still very little evidence of human-to-human transmission.
Thank goodness. So in these human cases, how has H5 presented? What percentage of the cases are asymptomatic, being picked up because there's one incident case? And then in those who are symptomatic, do typical host characteristics tip the scale, make it more severe, like age, immune status? Or is this virus truly different? Is it like the virus of the 1918 flu that was infecting younger people who are perfectly intact immune-wise?
Yeah, it's good to bring this point up because it's often erroneously referred to as a highly lethal infection in humans. Historically, so over the last 25 years, we've seen close to 1,000 cases, of which I think 400 were lethal. And some people then divide 400 by 1,000 to come to a case fatality rate of 40%. But this is clearly wrong because these 1,000 cases are those that have been reported to the WHO, and to be reported in many of those countries in Asia or Africa, the cases would already be hospitalized. So you're really only counting the hospitalized cases. You're ignoring the mild cases that never went to see a doctor or never got diagnosed. It's difficult to really estimate what the true incidence of infection was, but there have been serological studies around poultry workers and around live markets in Asia where hundreds and hundreds of cases were identified with H5 antibodies that never reported to a doctor and must have undergone a mild or even asymptomatic infection. So we don't really know the case fatality rate and how hot this virus really is. The latest 14 cases in the US were all mild. They were cases of conjunctivitis, so infection of the eyes, for instance, related to the exposure to dust in poultry farms or to milk in dairy farms. And some of these individuals also had mild respiratory symptoms, but really not any severe disease at all. Over the last 10 years or so, we've seen very few fatal cases and more mild cases, probably because these cases were diagnosed in countries that are closer following the situation and also actively seeking for infections around culling operations or cleaning operations in the agricultural sector. Then we see actually quite a large number of mild infections and not just the fatal cases as they were reported from Asia and Africa in the first 10 years of the outbreaks. So it's really hard to get at grips for what is the virulence of this virus. There's one little point I can add to that is of course, over the years, there have been numerous animal studies being conducted in mice and ferrets and primates in the lab that I would say that this is still a pretty hot virus, comparably hot to other pandemics that have been tough, like 1918 or 1957 or 1968. So these viruses can be a little bit more virulent than a typical seasonal flu virus. But the numbers we sometimes are presented with, a 40% case fatality rate, is certainly not anywhere close to the truth.
That's helpful to know. And I think that's a really good point that when you look at reported cases as the denominator for something that's not well tested, that obviously skews that case fatality rate pretty drastically. And so these numbers that people read just based on documentation can be quite scary. But there's a whole massive population of asymptomatic or mild carriers that is never included. Along those lines, you mentioned at least the US cases, a lot have been conjunctivitis, very mild respiratory symptoms. How else is there sort of similarities or differences between the typical seasonal influenza and this avian influenza that we're thinking about now? Is there the same thing of abrupt onset of fever, malaise, other things that people keep in mind? Or is it just very different from a range of symptomology?
Yeah, it is quite different, I think. So one important thing to note is both related to the transmission and to the infection itself, is that the hemagglutinin attaches to receptors on our airway epithelium. The human flu viruses use a different receptor than the avian flu viruses. So both of these viruses bind to sialic acids. So these are the terminal sugars on glycosylated proteins that are embedded on our epithelium. But bird flu viruses bind to 2,3-linked sialic acids, and human flu viruses bind to 6-linked sialic acids. Now, these 2,6-linked sialic acids are abundant in our upper airways, and the 2,3-linked sialic acids are more abundant in our lower airways. This relates, I think, a little bit to the pathogenesis and the transmission properties as we've seen it. The human flu viruses therefore bind to our upper airways, to cells in our nose and our throat, much more efficiently than bird flu viruses. And bird flu viruses don't do that so well, so that's why you don't see these infections being abundant in the upper airways with only mild respiratory symptoms, if any, and poor transmissibility, is because these viruses really are not adapted to replicate and spread in the upper airways of humans. So in the past, in the first 10 years of the H5 outbreaks, we've seen a couple of hundred of fatal cases. And this is in the rare instance that these bird flu viruses reach the lower airways and then cause a massive pneumonia because the receptors are abundant there. And so these humans then suffer from a severe pneumonia and acute respiratory distress syndrome and die as a consequence of that. But it's really a rare phenomenon only when the virus gets access to the lower airways. And so the bird flu viruses really don't cause the same type of symptoms as seasonal flu viruses, in part at least because of this difference in the receptor specificity of these viruses. It's interesting to note that the human eye actually has alpha-2,3-linked sialic acid. So this is the avian flu receptors, and that's why you see sometimes that bird flu viruses cause conjunctivitis, and in fact do that more frequently than human flu viruses. So this is all related to the receptor specificity in part of these viruses.
So it's not just exposure.
It's exposure and intrinsic properties. Yeah.
Very interesting. So speaking of diagnosis, how is the diagnosis being made right now? And what is the real availability of tests for avian flu should this become a real human problem, let's say? Is there a danger that we would face another first wave COVID experience where we would have a lack of testing material up front, lack of infrastructure, and there would be slow turnaround times?
The gold standard for flu, as for most respiratory viruses now, is RT-PCR, and the testing capacity, I think, for that is rather large. So the flu monitoring is routinely done by national influenza centers and associated laboratories with quite some capacity already throughout the year, because a lot of flu diagnoses are being done to monitor flu viruses for the WHO vaccine strain selection process. And so these diagnostic tests for H5N1 have been rolled out globally throughout all the national influenza centers. Also, I think it's fair to say that due to COVID, in general, the RT-PCR testing capacity is large. So it should be possible that if the need arises to do massive testing, that this could be rolled out really quickly because the test is already there. We have practiced this a little bit during COVID on how to scale up this process, and so this could be done again. Also, for flu, there are rapid tests available, lateral flow devices, quite similar to those employed for COVID. So I think that worst come to worst, we actually have experience now from COVID how to roll this out quickly. The test would be the same. People would be swabbing noses or throats and either testing those by rapid tests or by RT-PCR tests.
Reassuring.
Ron, just to jump onto that point, do you think that the sampling for these rapid tests would be different based on how this virus focuses more on the lower respiratory tract versus the mucosal membranes of the eye? Or is it that there's a change in the virus where it now has affinity for the upper airways? It would be the same sampling? Or is it just there's enough there just to be able to sample just to see with these rapid sensitive tests?
No, that's a good point, Nav. Thanks for bringing this up because, of course, currently, when there are outbreaks ongoing in poultry or in cows, the testing needs to be extensive. So if people present with conjunctivitis, you should test eye fluid, not respiratory fluid alone. Certainly, any suspect case now of poultry workers or farm workers should be more extensive than just a throat or a nose swab. The throat nose swab testing that I was referring to would be more in the case we would be facing an early pandemic phase, that this could be rolled out. But currently, certainly the sampling should be different. And also, of course, clearly, any person presenting with lower airway symptoms or severe pneumonia, we should definitely not forget to sample that site as well.
Yeah, thank you for that clarification. We have to keep thinking about how things might be changing in terms of the presentation versus what's going on now versus what the preparedness needs to be in the future.
There's one more remark to be made, if I may, is that we know that mammals that consume virus through contaminated meat or contaminated milk frequently develop neurological symptoms. And we've seen massive brain infections in wild mammals. Most species of wild mammals are diagnosed for bird flu because of neurological symptoms. This is something that medical doctors should keep in mind when they are seeing unusual cases of encephalitis or neurological symptoms, that they might want to think about asking about any contact with flu-infected animals.
That's something I was not aware of. In the 1,000 human cases that we've had, have there been documented meningoencephalitis cases?
Very few in those, but most of those people were exposed through the mouth or the respiratory tract via aerosol or something like that. Whereas we have noticed that when most mammals get infected by feeding on infected carcasses or by drinking contaminated milk, when the virus gets directly entered in the gastrointestinal tract, that it is more likely that the virus will reach the brain. We've done experiments here in Rotterdam by infecting cats, letting them consume infected chicken carcasses, and then you'll see very rapidly neurological symptoms. And also all the wild mammals where H5N1 is diagnosed, the vast majority of those are diagnosed with neurological symptoms. And we think this is due to the large amount of virus entering via the gastrointestinal tract and then reaches the brain via the hematogenous route.
So don't eat any dead birds, Nav.
Yeah, that'll be off my diet.
And don't drink raw milk.
Just another reason in a long list of reasons not to consume unpasteurized milk. So, Ron, I'm a pharmacist, and I always skip ahead to treatments, which is a purview that I care about. What can you tell us about what's recommended now for these human cases of avian flu that we've seen so far? Are there antivirals recommended in these cases? And is there any evidence, clinical or preclinical, to advocate for the use of this?
Yeah, so the same antivirals that are prescribed for seasonal flu also work for avian flu, and to the same extent. So we have oseltamivir, zanamivir, which are the neuraminidase inhibitors. We have baloxavir, which is a polymerase inhibitor. And those drugs have been shown to also work against bird flu virus. Now, there are limitations with these drugs because you have to start treatment as early as possible. They are direct-acting antivirals. and direct acting antivirals against acute virus infections, you really have to come in early to have a major impact. These drugs, they work if you start treating early. If you diagnose early and you treat early, you can stop a further replication of the virus, but they are less effective, or they are not effective if you start treating after the damage is already done. These drugs are also sometimes used prophylactically. So we have experience here in the Netherlands using oseltamivir for the people that are involved in culling and cleaning operations in the poultry sector. And prophylactically, these drugs work fabulously. You can really prevent any infection in those poultry workers. But therapeutically, you have limited options, and only when you can come in early.
I think that's a good point about what early means, right? So when we think about seasonal influenza, there's clearly a relationship between the earlier you start treating with antivirals like neuraminidase inhibitors, the less duration of your symptoms there is. So is that window still similar, 48 hours? Is the viral kinetics still similar in terms of when it peaks out at that time as we think about with seasonal influenza?
Yes, it's very similar. Indeed, you have a window of about 48 hours, and you will reduce symptoms with 1 or 2 days, so you shouldn't expect too much, but you do directly block replication at the moment you start this treatment, and therefore we still recommend the use of these drugs just to make sure that the virus stops replicating and reduce the spreading.
In addition to pharmacologic prevention, how should people protect themselves from exposure? What kind of personal protective equipment is being recommended right now for avian flu?
The first recommendation is, of course, to stay away from sick animals altogether, right? So for the general public, if you see a bird or a cat with neurological symptoms, stay away from it. Don't try to pet it. And if you do, protect yourself, because the animal is sick because of some virus infection. It might jump onto you as well. If you come in contact either professionally, because there's another need to, then you can protect yourself by wearing a face mask, an N95 respirator. In the case of bird flu, definitely also goggles to prevent the exposure of your eyes against conjunctivitis. We wear gloves, of course, that can be then taken off cleanly after touching the animal. And for professional workers, people usually go in with coveralls and then waterproof aprons, rubber boots, anything that can be disinfected well. Because, of course, there's two things you need to do. First and foremost, you need to protect yourself. But also, if you go into a premise with bird flu, you don't want to drag that bird flu virus onto new premises or other situations. And so you need to clean yourself up afterwards. And this is done by wearing suits that can be cleaned easily. But you protect yourself mostly by goggles, face masks, respirators, and gloves.
Where are we from a vaccine development standpoint when we think about population level prevention interventions?
Ever since 1997, the WHO system has made vaccine strains available for use when it's necessary. Every year or two, whenever there's a new variant of H5 popping up somewhere in the world, the WHO system updates the vaccine strain. So they are making strains ready for employment by the vaccine industry, so that the vaccine industry that now makes our seasonal flu vaccine can rapidly shift to produce H5 bird flu vaccine. That's important to know that this is continuously ongoing. The WHO system, I think, has at least made 25 updates of this antigens that can be put into production facilities when the need arises. And so that would mean that after somebody pushes that button saying, okay, now we're going to stop making regular seasonal flu vaccine and we're going to start making H5 vaccine, it takes about 6 to 9 months to do that. But we, in principle, have that process in place. Now, some countries in the world have also stockpiled already some of these vaccines, like the USA has stockpiled for the entire American population using those historical H5 vaccines. And it's fair to assume that those historical variants, although they're not a perfect match with what's currently circulating, are going to be useful in the case a pandemic might hit. The last point to make is that during COVID, we've had good experience with new vaccine platforms. Those companies, after the COVID pandemic, have moved up instantly to also employ the same vaccine platforms for bird flu vaccines. And there are now numerous trials ongoing with mRNA and vectored vaccines that should be effective also against H5. It's not so clear yet how well they would work compared to COVID, but it's anticipated that they will work quite well also. Certainly with the mRNA technology, of course, you have the option for more rapid employment of a pandemic vaccine. And so it's anticipated that rather than the 6 to 9 months that would be used for a conventional vaccine, you would be ready to go here in maybe 3 months' time. Since the phase 1 clinical studies are already ongoing, it can be expected that in the next flu pandemic, whether it's H5 bird flu or another flu virus, those vaccine platforms will deliver quickly also.
Even though vaccines against seasonal flu don't actually work against avian flu, they're being strongly recommended in an overall strategy against avian flu. Can you explain this to us?
Yes. So currently, the H5N1 virus is not a virus that is efficiently transmitted between humans and therefore not a direct pandemic risk. All international health agencies estimate the risk of this H5 virus as it is to be low to the public. But we know that flu viruses, because they have a segmented genome, the genetic material consists of small separate pieces of RNA, they have an ability to what we call reassort. When a human or another host gets infected by a human flu virus and an avian flu virus, then these two flu viruses can exchange genetic material, and thereby the avian flu virus can acquire traits that allow it to replicate and spread better in humans. This is something that we want to prevent. So what we do not want to see happening is that the people who are now active in the dairy industry or in the poultry industry cleaning up viruses, that they would become infected with a bird flu virus and a human flu virus at the same time and thereby trigger perhaps a next pandemic. We can prevent human infections with human flu vaccines and thereby reduce the chance of double infections of these people. And with that, we hope to reduce the risk of emergence of reassortant viruses. And this has been done throughout the world, not just for H5 flu viruses, but also for people who are working in the pig industry and are exposed to swine influenza viruses. It's always smart to vaccinate those people that are active in the swine industry against human influenza virus to prevent double infections.
So we don't want to become unwitting viral engineers.
That's right.
Ron, I know you didn't mention fortune teller as one of your alternate careers that you wish you had, but I'm going to ask you this question anyway. What do you predict for this upcoming flu season? Are you highly concerned about some of these problems that could potentially be an issue in terms of reassortment or larger outbreaks just based on the personnel dynamics that you see in farming industry? Are you worried about human-to-human transmission, or is it just stay vigilant level in your mind?
I find the situation in North America rather alarming. The reason is how widespread this outbreak is in cows. So I would like to see this outbreak stopped this fall, preferably before the human seasonal epidemic starts, right? So we have an opportunity to stop this outbreak before the flu season in humans start and thereby reduce any risk of double infections. This is not just for the human health aspect, but also for the animal health aspect. We should try to eradicate this virus from domestic animals when we can. If we let this linger, we know that animals could be shipped into other parts of the world and viruses will spill over from the cow population into poultry and into cats and into mice and I don't know what other animals. The dairy industry is really not equipped to protect the milkers and the farm workers against spills with milk. This has never been a problem, and the whole design of the processing system is such that spills cannot be prevented and human infections cannot be prevented well. The best thing to do now is to eradicate this from the dairy industry as fast as we can. And if we set the target before the next flu season, then we can stop the discussion about chances of reassortment and things like that. Because if we separate these things in time, then we're done.
Do you think it's feasible to stop this epidemic in cows at this point?
Yes, of course it's feasible. We know how to stop these outbreaks if we stop moving animals around and really let the infections die out herd by herd. Then I don't see how this is going to spread further. But it starts by massive testing of cows in the US, stopping any movement of cows that are possibly infected. But epidemiologically, we know how to stop outbreaks like this. But it does require a strong commitment. It's going to cost quite a lot of money.
That's really the question.
Yes, of course. But if you let this linger and this becomes enzootic in cows in North America, it's going to cost money for many years to come. There's really a lot to be gained from doing a strict biosecurity enforcement and strict epidemiological control now to prevent any problems in the future. See, right now it's in cows, but if you know it's in cows, it's going to end up in pigs. It's already spreading over into poultry. It's going to spread into wild animals again. This is going to be a mess. We need to stop it now, preferably before the next flu season in humans. That would be ideal.
Ron, this is not necessarily your jurisdiction, but are you aware of the farming industry cooperating to this degree that the epidemic could be stopped like this season? Or is there some pushback?
I do not have all the details about all the farms and all the states in the US. There seems to be differences from state to state. I'm disappointed that there's not a stronger push from the federal authorities and that much of the decision making seems to be state by state, which I find a missed opportunity. But yeah, I'm not the boss of the USA, so I have no say there. We can only make recommendations as scientists or as clinicians. As a scientist, my recommendation is stop this while you can and do what it takes. Of course, it's going to cost money, but if this lingers on for 1, 2, or 3 more years, it's going to cost much more money. And it's going to really put pressure on the health system, and we run a risk of spillover of this virus into wild animals, poultry, pigs, time and time again. So the damage could be huge.
Yeah, I couldn't agree with you more. If you think about it, the US has their strategic national stockpile, where they stockpiled millions of vaccines for years. It only seems right to continue along that path and do the things necessary from a One Health perspective, right? Where you're thinking about the interactions of humans and animals and the environment, and finish out the job in terms of making this a non-issue or a non-pandemic or something that hasn't erupted to something worse than it could potentially be. You hit on these action plans of what needs to be done in terms of quelling this issue from a dairy cow standpoint, a farming standpoint. And then you mentioned that as scientists, we can make these informed recommendations. So what other research priorities do you think are important for not just what's going on in the US from a public health standpoint, but even for other scientists around the world looking at and assessing avian flu?
I think the main message should be prevention. So we should try to stamp out dangerous viruses in domestic animal populations, either by culling, like we do here in Europe, or through vaccination strategies, which is employed in several other countries in the world, but is now also starting to be considered in Europe. Improving vaccines for domestic animal populations can be a huge win to prevent infections in humans. That is one area where I think scientists should do better. Prevention on the whole, the viruses jumping over from wild hosts into domestic animals should be prevented, and then the contact between the different species of domestic animals should be prevented. This should be the main target, is to keep dangerous viruses out of domestic animal populations. And if we are successful in that, then we will be preventing pandemics in the future. This can work. It's not going to be waterproof, and therefore we also need to develop better mitigation strategies. One is, of course, vaccines. We've seen that with COVID, after the vaccines were released, we could all go to a restaurant or a movie theater again. And so it's a no-brainer to invest more in better vaccines. Pandemic vaccines. Tony Fouchier already called for a search for a universal flu vaccine a decade ago. I think that should be high on our list. Now, if we can put people on Mars or the moon, then we can also make universal flu vaccines with that type of money. So I think that sort of program should continue. And I'm not personally a big fan of direct acting antivirals for acute virus infections because you're usually too late, but biological response modifiers that can help you recover from infection or make you resistant to infection, things like that should also be developed. And some of these might be rather generic to multiple respiratory viruses. My message would be try to prevent whatever you can at whatever cost, but also work on the mitigation strategies for those cases where we cannot prevent.
What are your final messages that you want to leave our listeners with? And these are listeners who are infectious disease doctors, clinical microbiologists, pharmacists, who this fall will be having discussions with patients, with school teachers. What things do you want them to know about avian flu in 2024?
It's important for everybody to realize that these viruses are all around us all the time. Bird flu viruses have been with wild birds for tens of thousands of years, have co-evolved with these birds, and are omnipresent. Every fall here in the northern hemisphere, these viruses are out there. And in principle, those viruses are not dangerous to us. They can become dangerous if they spill over into other mammals and adapt. And if we let this happen, then they might become more dangerous. Also, if we don't detect them on time, then they can evolve and become more dangerous to humans. They can become more dangerous in humans. We have to have these monitoring systems in place to detect these viruses when something goes wrong. But then we also have to take responsibility to solve the problems when they are happening. I hope that all the infectious disease specialists in the world will call for a push in the USA to get rid of this virus from cows and prevent it from spreading in the animal sector.
Thank you so much to Ron Fouchier of Erasmus MC in Rotterdam, Netherlands. And thank you for listening to Communicable, the CMI Comms podcast. This episode was hosted by Nav Narayanan and Angela Huttner, editors at CMI Comms, Estimates Open Access Journal. It was edited by Dr. Katie Hostetler and peer-reviewed by Dr. Simon Galmiche of the Emerging Diseases Epidemiology Unit, Institut Pasteur, Université Paris-Cité, Paris, France. Theme music was composed and conducted by Joseph McDade. This episode will be citable with a written summary referenced by a DOI in the next 8 weeks. And any literature we've discussed today can be found in the show notes. You can subscribe to Communicable on Spotify, Apple, wherever you get your podcasts, or you can find it on Estimate's website for the CMI Comms Journal. Thanks for listening and helping CMI Comms and ESCMID move the conversation in ID and clinical microbiology further along.